right, let's dive into something that sounds like it's straight out of science fiction, but is actually getting closer to reality every single day. We're talking about the quantum internet. And this isn't just about faster streaming. This is a network designed to be the backbone for a future civilization that spans our entire solar system.
So let me just start by throwing a question at you. Imagine you need to send a message to a colony on Mars, and it has to be completely 100% secret. I mean, a message that no one, not a hacker, not a rival government, not even a supercomputer from the future, could ever possibly read. That idea, that promise of unshakable security, is really the core of what we're about to explore. Now, to really get why we need this crazy new network, we first have to talk about the one we use every day. The internet we have now is amazing, right? But it's starting to show some serious cracks, especially when we look to the future. It's facing a couple of fundamental problems that are about to become a very big deal.
Okay, so here are the two big vulnerabilities. First up, distance. You know, the speed of light sounds fast, but across the solar system, it becomes a huge bottleneck. It makes real-time communication just impossible. And second, and this one's a biggie, security. The encryption that keeps all our data safe right now, well, it turns out it's completely breakable by the next generation of quantum computers. These two problems mean we need a whole new way of thinking about networks.
And this number really drives that distance problem home. Depending on where the planets are, a signal sent from Earth to Mars can take anywhere from 3 to 22 minutes to get there. That's one way. So a simple hello, how are you? And I'm fine, thanks, could take almost an hour. You want to try to control a rover in real time? Forget about it. It's just not going to happen with the tech we have now.
So here's the beautiful irony. Quantum computers are this massive, looming threat to our security. But it turns out that quantum physics itself also gives us the ultimate solution. This new network won't replace the internet we have, but it's going to run alongside it, like an ultra-secure secret layer that's built on the totally weird and wonderful rules of the quantum world. The whole thing starts with something called a qubit. Now, a normal computer bit is simple, right? It's either a 0 or a 1, on or off. But a qubit, thanks to this wild property called superposition, it can be a 0 and a 1 at the exact same time. The best way to think about it is like a spinning coin. While it's in the air, before it lands, is it heads or tails? Well, it's kind of both. And that ability to be in multiple states at once completely changes the game for information. And this is where things get truly mind-bending. It's a phenomenon called quantum entanglement. You can take two qubits and link them together in this special way so their fates are forever intertwined. If you measure one of them and it's a 0, you instantly know the other one is a 1. It doesn't matter how far apart they are. They could be in the same room or on opposite sides of the galaxy. The connection is instantaneous. This is the absolute backbone of the quantum internet.
In fact, this idea was so strange, so counterintuitive, that Albert Einstein himself famously called it spooky action at a distance. He really wasn't a fan of the idea. But guess what? Decades and decades of experiments have proven that it is very, very real. And it's the spooky connection that we're going to harness for communication.
So how does all this spooky stuff make something unhackable? Well, it all comes down to something called quantum key distribution. That entangled link between two particles is incredibly delicate. The moment an eavesdropper tries to look at it, to listen in, the very act of observing it shatters the quantum state. It just collapses. And that collapse is instantly detected by both the sender and the receiver. It's like a built-in alarm system. The connection doesn't just get broken, it screams that it was tampered with. It's security that's literally guaranteed by the laws of physics. Okay, so the theory is absolutely wild. I get it. But how do we actually build this thing? I mean, how do you take this incredibly fragile phenomenon and make it work across the vast, empty distances of space? The answer is a network of what are called quantum repeaters. You see, entanglement can fade over long distances, so you need a chain of relay stations to keep the connection strong, kind of like signal boosters for Wi-Fi. You could have a hub on Earth that creates an entangled link with a satellite near the moon. That satellite then creates a new, fresh link with a station orbiting Mars, and so on, creating this perfectly secure chain all the way across the solar system. Now, I have to be super clear about one thing, because this is a huge misconception. This does not mean we can send messages faster than the speed of light. You can't. What happens instantly is the creation of a shared secret encryption key between two places. Once you and your friend on Mars have that unhackable key, you use it to encrypt your message, which still has to travel at the good old speed of light. The innovation here isn't speed. It's perfect, instantaneous security.
And please don't think this is just some theory locked away in a university lab. This is happening right now. There is a global race to build this future, with countries pouring billions of dollars into being the first ones to master this technology.
And the race is definitely on. Back in 2016, China launched its Micius satellite and made history by proving this could actually work from space. Since then, the US has put out a blueprint for a nationwide network by 2030, Europe has launched its own Quantum Internet Alliance, and India just launched its national quantum mission to get in the game with satellite networks. The foundations for this future are being laid as we speak.
So let's just dream for a minute. Let's step into the future. What does our world, heck, what does our solar system look like once a quantum internet is fully up and running? What does this technology actually let us do? Honestly, the possibilities are just staggering. Here on Earth, it means financial systems, government communications, military networks that are physically impossible to hack. In space, you could link quantum computers on different planets to create one single solar system-sized supercomputer. It would be the secure communication network you absolutely need for any real colonies on the Moon or Mars. You could even link telescopes all over the solar system to create a virtual lens powerful enough to see details on distant exoplanets.
When you boil it all down, what we're really talking about here is building the nervous system for an interplanetary civilization. You know, the first quantum experiments happening today, they're just like when the first message was sent on the ARPANET back in 1969. Nobody back then could have possibly imagined what our internet would become. We are at that exact same starting point for a network that will one day reach out to the moons of Jupiter and even beyond. So, building the quantum internet really isn't a question of if, it's just a question of when. Yeah, it's a huge challenge, but the work is already underway. And that just leaves us with one last pretty fun thought to chew on. Once this network is live and you can make a perfectly secure call to anywhere in the solar system, which planet are you going to call first?